Convection. So convection is the transfer of thermal energy by the movement of heated materials. So we kind of think that hot air rises. So then obviously cold air must sink. So what happens here is the cooling of matter causes it to condense, which increases its density because now you have more material in a smaller space, or for the same volume of material, it has a greater mass now. So for example, 1 cubic centimeter of air would weigh more than it did before it condensed. Now, cooler matter then sinks due to gravity. So if that volume of air is now more massive, it's basically going to be heavier. So it's going to sink because gravity pulls it down. Now, as this cooler air gets pulled down, or this cooler matter gets pulled down, the warm matter basically gets pushed up. So our hotter air, for example, will get pushed up. And this basically results in a convection current. We have an example here with a beaker and some food coloring. Okay, so you got an ice cube that's in the beaker right here. You have water in the beaker, and then you put some food coloring in here. And you're also heating the beaker from this corner over here. So it's hot here, it's cold here. Well, the cold water basically sinks, the warm water rises, and this creates a current inside the beaker. Okay, so you get a convection current. So convection in the mantle. So Earth's mantle is primarily made of solid material that is heated unevenly by radioactive decay from the mantle itself and the core beneath it. So this causes solid rock to slowly flow like a soft, pliable plastic. So part of the mantle is too cold to flow and is attached to the tectonic plates. Now, as the mantle material cools, it slowly sinks toward the center of the Earth, causing heated material to be displaced and rise up. So we have this material, this cooler material that is sinking. And again, it is basically going to push this warmer material up out of the way and displace it. Now, these currents flow at rates of only a few centimeters per year, so these are very slow convection currents. Now, how does this cause plate movement? Well, the rising material and the convection currents spread out as it reaches the upper mantle. So we have this rising material here that basically rises up, hits the bottom of the plates, and basically has to spread out, has to go somewhere. It can't keep going up. So it hits those and it starts to spread out. Okay, this causes an upward and a sideways force. So we have forces basically pushing up, and we have a force pushing out. So we have our forces here that are going to cause the lithosphere to split at the boundary and basically start moving towards the sides here. So now the downward part of the convection current, which occurs on the edges here, the downward part of this current occurs where a sinking force pulls tectonic plates downward at convergent boundaries. So basically where the current flows down, it starts to basically pull these plates down with them.